Hello everyone. Let's talk about the linear regression model in this lecture. In practice, you can find one factor sometimes influence another factor. For instance, a customer's yearly income can influence how much he will spend every time when he visits a grocery store. The more yearly income the customer has, the more he probably will spend every time when he visits a grocery store. The time a student spends on the exam review will influence his performance in the exam. The more time he spends on the review, the more points he will probably get in the exam. If you find one factor can influence another factor, you can use regression model to find out the relationship between the two factors. If you would like to present this relationship in a mathematical way, you can get an equation like the one on this slide. Y equals to beta sub 0 plus beta sub 1 times x plus epsilon. Let's talk about these factors one by one in this equation. Y in this case is called a dependent factor. It is a factor being influenced by another factor. X in this case is called an independent factor. It is the factor that influences the dependent factor Y. For instance, if you believe the time a student spends on the exam review will influence the points the student can get in the exam, then the dependent factor should be the point the student can get in the exam. The independent factor should be the time the student spends on the exam review. Beta sub 0 is a constant. Beta sub 1 is the coefficient of the independent factor. We want to use some technique to find the values of beta sub 0 and beta sub 1. What about the epsilon? Epsilon is called the error term. We are very likely to make some mistake when we estimate the values of beta sub 0 and beta sub 1. So we record all the errors as epsilon in this equation. How can we estimate beta sub 0 and beta sub 1? Before I introduce the regression model to everyone, we must figure out which values are known, which values are unknown in this equation. Can we find the values of x and y from practice? Yes, we can. For instance, we can do a survey among students. Ask them how much time they spend on the exam review, how many points they get from the exam. What are unknown? What values we don't know? The values of beta sub 0, beta sub 1, and epsilon are unknown. If we can find some way to find the values of beta sub 0, beta sub 1, and epsilon, plug them into the mathematical equation. Next time, if we just know the value of x, then we can predict the value of y. That will be great, right? The problem is, how can we find out the values of beta sub 0 and beta sub 1? This is what we are going to do. We want to draw a sample from the population that has the factor x and y. And then we want to use this sample to estimate the values of beta sub 0 and beta sub 1. To differentiate the population and the sample, we use b sub 0 to represent the constant in the sample. We use b sub 1 to represent the coefficient of the independent factor in the sample. If we are able to find out b sub 0 and b1 in this sample, then we can say beta sub 0 and beta sub 1 will have similar values. What about the error term epsilon? When we make the estimation, when we use the sample to predict the population, we try to minimize the error. So at this moment, let's ignore epsilon. We'll talk about this error term after we made the estimation. Now let's see an example. I want to use this example to show you how to implement the regression model in Excel to estimate the values of B sub 0 and B sub 1. And then what's the managerial implications to managers after we get the results. Joe is developing a fitness mobile app. He believes that a user's yearly incomes will influence the time the user spends on this mobile app every week. Joe's assumption is that the more incomes a person has, the more resources he can spend on fitness information, he will become more health conscious. Therefore, he will use the mobile app more. Because Joe's mobile app could have millions of users, it's impossible for him to survey the entire user population. So Joe drew a sample of 10 users from the entire user population. And he tried to use these 10 users to predict the relationship between the user's yearly income and the time the user spends on the mobile app. In this case, which one is the independent factor? Which one is the dependent factor? How the independent factor will influence the dependent factor? Because we believe that the user's yearly incomes will influence the time he spends on our mobile app. So we want to use the user's yearly income to predict how long he will spend on the mobile app every week. The independent factor in this case should be the user's yearly incomes. The dependent factor should be the time the user spends on our mobile app every week. After Joe identifies the independent factor and the dependent factor, he drew a sample of 10 users. This table shows the 10 users' responses to Joe's question. We give each user an ID number, and then we record how much he can get as the yearly incomes and how long he spends on our mobile app every week. For instance, the first user ID 1, he got $100,000 as a yearly income, and he spends averagely 9.3 hours on our mobile app every week, and so on and so forth. Now I want to show you how to estimate the values of B0 and B1 by using the software Excel. Once you open the Excel software, you get the data set in the software. As you can see, we have 3 columns. The first column is the ID number. We give each user an ID number when they take the survey. We really don't need the ID column in the data analysis process. This is only a label to help us identify who answered what. In the second column, we have the yearly income. We record each user's yearly income. And then in the third column, we record how long he or she spends on our mobile app every week. In Excel, when you try to estimate the values of B sub 0 and B sub 1, you have 2 ways. The first one is an easier way, and the second one is a little more challenging. Let's take a look at the easier way first. Select a data range from cell B1 to cell C11. B1 to C11. As we just discussed, we really don't need the ID column, so we don't need to select the ID column. Select from B1 to C11, and then click Insert tab on the top, and then find the Charts region, and then find the Scatter chart. Click on the upside down little triangle under Scatter, and select the first option, the first scatter chart. As you can see here, Excel gives you a trend on a plane. This shows you some kind of relationship between the user's yearly income, as you can see $100,000, $800,000, and the time the user spent on your mobile app. For instance, 1 hour, 2 hours, 3 hours to 9 hours, 10 hours. Excel shows you some kind of relationship. We want to show the relationship even more clearly. So click on the dots. By the way, what do the blue dots represent on the plan? They represent each user's responses to our questions, right? They are the real observations in our data set. For instance, the blue dots on the very top, if you move the mouse over the blue dots on the very top, you can see that it represents the first user's responses to our question. He got $100,000 yearly income, and he spent 9.3 hours on our mobile app. So if you move the mouse over other dots, you will find they represent the real observations, right? Now we want to show the relationship between the yearly incomes and the time. In other words, we want to find a value for B sub 0 and B sub 1. We want to select any dot on this plan. If you haven't clicked on any dot on this plan, please do so. Click on any dots on this plan. And then right-click on the plan. Right-click on it. And then choose Add Trend Line. On the left, you want to make sure that Trend Line Options is selected. And then on the right, choose Linear, because we want to perform a linear estimation. And then at the bottom, check the box before Display Equation on Chart. And then click Close. Now you can see that we got the equation, the estimated equation on the plan. This is exactly what we want, right? Let's make the chart larger so we can see the equation clearly. Y equals to 0.0678 times x plus 1.2739. Do we have a value for B sub 0? Yes, we have. B sub 0 represents the constant value, right? In this estimated equation, we do have a constant. It is 1.2739. What about the B sub 1? It is the coefficient of the independent factor, right? The coefficient before x. Do we have a value for that? Yes, we do. The value is 0.0678. So we got the estimated values for B sub 0 and B sub 1. What is the purpose of this estimated equation? As we discussed in the beginning of this lecture, since we have get the quantitative relationship between independent factor and dependent factor, next time if we only know the user's yearly income, we can then use this estimated equation to predict the value of the dependent factor, which is the time the user will spend on our mobile app every week. This is very nice, right? Another implication from this example is we can present the estimated equation in a graphical way. What is the graphical representation of the newly estimated equation on this chart? As you can see on this chart, around the blue dot, we have a new black line. This line is a graphical representation of the equation we get on this chart. Later in this lecture, we'll also talk about how Excel software chooses this line for the user. Around the dots, we can draw a lot of lines. Why Excel software only chooses this line? Because this line is a graphical representation of the newly estimated equation. If you understand how Excel software draws this line around the dots, basically you will also understand how Excel software finds the estimated values for B sub 0 and B sub 1. As I just said, this is the easier way for us to find the estimated value for B sub 0 and B sub 1, right? Now let's take a look at the more advanced way to find those values. First, let's select the chart. You can click the blue boundary around the chart and then press delete button on your keyboard, and then the chart will be gone. Now the data range is still selected, right? We want to click on any empty area, any blank area in the software to deselect the range. We don't want the range to be selected anymore. And then you want to click on the Data tab. Click on Data tab. On the very right end, you want to check if you have a button called Data Analysis. If you don't have it, click on the File tab on the top. Click on File, and then click Options. On the left, click on Add-ins button. Click on Add-ins on the left. And then at the bottom, click on Go for the Excel add-ins. If you don't have add-in show up in the drop-down list, click on the drop-down list and then choose Excel add-ins and then click Go button. On this window, check the box before Analysis 2-pack. Check the box next to Analysis 2-pack, not the 2-pack VBA, just the Analysis 2-pack. Check this box and then click OK. And then if you click on the Data tab on the top, you will find the Data Analysis button show up on the very right end. Click on Data Analysis. And then on this window, scroll down and find the Regression function. Select Regression and then click OK. Now we need to identify the data range for the X factor and the Y factor, right? The first one is the Y factor. Click on the button next to Input Y range. Click on it and then select the range for the dependent factor. Sorry. We want to find the Y factor, so we want to select the range for the dependent factor. Select the range from C1 to C11. And then click the button to confirm. Second, we want to select the range for the independent factor. So click on the button next to Input X range, and then select the range from B1 to B11, and then click Confirm button. Next, you want to check the box before Labels. Check the box before Labels to select Labels. This indicates that the first row in the selected range includes the title row. The next option you want to check is the confidence level. Check the box before confidence level. Confidence level is a probability to which you are confident about the relationship you predict between the independent factor and dependent factor. As the name implies, how sure you are about the relationship between the independent factor and the dependent factor. Of course, it is a probability, so it is very subjective. You can use any number between 0 to 100 as your confidence level, right? But usually in practice, we choose 95% or 99%. So that means you are 95% sure about the relationship between the X factor and the Y factor, or 99% sure about the X factor and the Y factor. So we got the confidence level. What about the rest of the level? For instance, in this case, if we are 95% sure about the relationship between the user's yearly incomes and the time they spend on our mobile app, what about the rest of the 5%? That 5% is called the region of errors. Of course, we are not very sure about the relationship between the X factor and the Y factor in the rest of the 5%. And then you want to check the new worksheet apply. This means the analysis results will be shown in a new worksheet. And then click OK. Now we get the result. I believe some classmates may think, what is this? Don't panic. Let's take a look at the result and understand each factor, and then you can interpret the result. Because we want to find the values for b sub 0 and b sub 1, so we want to look at the bottom first. If you drag the report, you can find the coefficient for the yearly income is predicted as 0.067826. Is this the same number we get from the graphical chart? Yes, it is. This is the coefficient of the independent factor. And then if you move up, you will find the coefficient for a term called the intercept. It is 1.2739. Is this the same number we get from the chart? It is, right? This is the value for b sub 0, which is the constant term. The next important factor is the R-squared factor. It's in the section above. What does R-squared represent? It represents the percentage that your independent factor can explain the variance of the dependent factor. The value for R-squared always ranges from 0 to 1. The higher, the better. Of course, the higher the R-squared value is, the more variance your independent factor can explain the dependent factor. Let's talk about the questions we have so far. During our discussion, we left 3 questions, right? The first one is, how does Excel estimate the values of b sub 0 and b sub 1? If we present the estimated equation on the chart, why Excel only choose one line around the blue dots? This is what this means, right? The knowledge is not required. However, I think it's interesting to know the method behind the Excel software. So we'll have a discussion about this. The second question is, how R-squared is calculated? By the way, when we mention R-squared in the future, we use the symbol, as you can see on this slide, R with power 2 to represent R-squared. This knowledge is required and is very important. So we will also have a discussion on R-squared calculation. The third question is, what is the managerial implication of the current linear model? What does this model mean to business manager? Why they need to care about this model? We'll talk about this too. So let's talk about the first question. How does Excel chooses the values for b sub 0 and b sub 1? Let's review what we did when we estimated the values of b sub 0 and b sub 1. We draw a sample from the population, and then we use the sample data set to estimate the values of b sub 0 and b sub 1. This is what we did in Excel, right? So on this slide, you can find a difference. I have y and y hat. What is the difference between the two? Here is the difference. Y represents the real values of a dependent factor in the data set. We can actually collect these real values from the user's responses in the survey, right? For instance, we ask each user, how long did you really use on our mobile app? The first user may answer 9 hours, the second one may answer 8 hours. We record these real values in our data set. When we get these real values, we can also calculate the mean of the dependent factor. We use y bar to represent the mean. What about y hat? Y hat is the estimated value of the dependent factor if we plug in a value of x into the equation. Now let's see an example. This is the sample data set we use to estimate the value of b sub 0 and b sub 1. What are the values for y? As you can see, the values in the red rectangle on this slide are all real values. They are reported by our users, so nobody can change it. They are the actual observation in our dataset. These are the values of dependent factor y. Based on this dataset, we estimated the value of b sub 0 and b sub 1. We get the equation y hat equals to 1.2739 plus 0.0678 times x, right? Now, if we only know the value of x, we can estimate a value of y. We use y hat to represent this estimated value. Now I have some questions for you. How long is the average usage time of this sample? In other words, what is the value of y bar? How can we calculate y bar? We just need to find the average value of all values in the red rectangle, right? This is what we want to find. Second question, for the first user, how long did he actually use the app? In other words, what is the value of his real usage time, the real time of dependent factor y? What is the estimated usage time y hat based on the estimated equation? What about the second user? Now let's use Excel to answer this question. The values in the C columns are real observation. They are value of y. So if we want to calculate the mean of the real values, we only need to use an equation in Excel. In C12, I want to type in equal sign average, and then the left parenthesis, and select the value from C2 to C11, and then the right parenthesis, and then press enter on your keyboard. Now we can get the value of y bar. The value is 6.7. This means from this data set, we can see that our users will use our mobile app averagely 6.7 hours every week. Next question. How long did the first user use our mobile app every week? We can find the real value from this data set immediately, right? If you look at cell C2, it shows the answer. The first user actually used our mobile app 9.3 hours every week. Next question. Suppose we don't know the first user actually spends 9.3 hours on our mobile app every week. We only know his yearly incomes is $100,000. We want to use the equation to estimate how long he will spend on our mobile app. So this is what we are going to do. In cell D1, I want to type in estimated time. And then I want to go back to the PowerPoint and copy this equation. And then paste it into cell D2. Click on D2, and then I want to type in equal sign and then paste the equation. Here I want to do some modification. I want to remove the letter X and then type in asterisk, and then click on cell B2. So this means we want to use the value in B2 and then the equation to predict how long the user will spend on our mobile app. Now press enter button on your keyboard. Now you can see that the estimated time y hat is 8.05 hours. We can do the same for the rest of the users in this sample. Do you see the little black circle in the lower right corner? This is called the autofill button. So if you drag the autofill button to the rest of the cells, you can get the estimated time based on the values in the B column and the equation. Now you can find that there is a problem in this spreadsheet. The estimated time is not precisely as same as the real time the user spent on our mobile app. For instance, for the first user, he actually spent 9.3 hours on the mobile app. But according to our estimation, we only get 8.05 hours. There is a difference between the real time and the estimated time. We call this difference residual. In cell E1, I want to type in residual. Residual represents the difference between the real observation and the estimated value for the dependent factor. This is also the mistake we make when we estimate the values. For the first user, I can calculate the residual for the dependent factor is, I want to type in equal sign C2 minus D2. For the other users, I can drag the autofill button of E2 to the rest of the cells. There are some actually very interesting properties of residuals. First, the sum of the residuals in the dataset should be 0. Let's try it out in this example. So in cell E12, I type in equal sign SUM, and then left parentheses, and then select the data range, and then the right parentheses, and then press enter. You will get the sum of the residuals is 0. It's very interesting, right? Second, because residuals represent the errors we incurred during the estimation process, so when Excel estimates the equation between x and y, Excel software will make sure that the total of residual squares to be as small as possible. Now let's say according to the current value of b sub 0 and b sub 1, what is the total value of residual squares that Excel software gives us? In cell F1, I type in residual squares. And then in cell F2, I want to type in equal sign E2, and then asterisk, and then click E2 again. This means I use E2 to multiply E2 to get the residual square, right? Press enter button on your keyboard. And then click on F2 and then drag the autofill button of F2 to the rest of the cell. And then I want to calculate the total value of the residual squares. So in cell F12, I type in equal sign SUM, and then parentheses, and then select the range from F2 to F11, and then the right parentheses, and then press enter on your keyboard. I get 8.02. This is the smallest total of residual squares that Excel can find for us, according to the dataset we give to Excel. In order to reach the smallest total of residual squares, Excel find out the value for b sub 0 must be 1.2739. The value for b sub 1 must be 0.0678. This is how Excel estimates b sub 0 and b sub 1. If we use the smallest total of residual squares to estimate the values of b sub 0 and b sub 1, this method is called the least squares method. In data analysis, we use the lowercase e to represent residuals. As we discussed earlier in this lecture, a residual is the difference between the real value and the estimated value of the dependent factor. And we want the total of the residual squares to be as small as possible. In order to reach this goal, Excel must find the optimal values of b sub 0 and b sub 1. We also talked about the graphical representation of the estimated equation. We said around the blue dots, we can draw a lot of lines, but Excel only chooses one line for us. Now you should understand that the least squares method is the selection criteria. Only this selected line can give us the smallest total of the residual squares. We kept talking about residuals, And the residuals represent the differences between real values and the estimated values of the dependent factor. Those are the errors we incurred during the estimation process. Does the word errors sound familiar? Do you still remember at the beginning of this lecture, we talked about the error term epsilon. Epsilon represents the errors we incurred during the estimation process. Since epsilon also represents errors, are epsilon and residuals the same? Yes, they are the same. In order to differentiate the error terms from the population and the sample, we use epsilon to represent the errors for the population, and we use the residuals, or the lowercase e, to represent the errors from the sample. At that time, I said we can ignore epsilon. Can anyone tell me why we can ignore epsilon? Do you still remember in the Excel software, when we calculate the total value of the residuals, what is the total value? It's 0, right? That's why we can ignore epsilon as well, because the total value of epsilons will also be 0. I'm not sure about you, but if I can put together something in a mathematical way, I always feel excited. It feels like I can resolve some mysteries by using science. It's really a good feeling. So far, we have talked about how we get the values of b sub 0 and b sub 1. It's not required for the exam, but as you can see, it's very interesting to know this knowledge. I want to stop here and take a break, and when we come back, we'll talk about the other 2 questions we left so far. How can we get the I-squared value, and then what is the managerial implication of b sub 0 and b sub 1? Let's take a break, and then we will come back soon.